All right, third time now trying this video. Keep getting interrupted. 8-9 enrichment. This is the notes that we were taking for the graphing systems of inequalities. We spent more time grading the last night's homework than we did going through these. So students asked if I would record this lesson as far as how to go through this. So I'm going to go quick, but you can always pause and rewind and all that stuff because I have to get out of here because I have a meeting. So first one. All right, put that in there already. Whenever we're looking at a system of inequalities, what we're going to do is we're going to try to solve for when both of them, any point for x and y in a plot on that coordinate would be true. So when I see a question that's already in slope-intercept form, and remember, slope-intercept form, y equals mx plus b. This is not the x-intercept. That is not the y-intercept. Those are values that can be put for any x and y. The y-intercept is going to be b. That's going to be our first clue. And then from that point, we can go use our slope. So for this first guy, my slope is going to be 2, because that's the m in the y equals mx plus b. And my y-intercept, I'm going to say y-int, is 1. So that's where it crosses, where the line crosses the y-intercept. So that means that would be right here. And since my slope for y is greater than or equal to 2x plus 1 is 2, that means I go up 2 on 2 over 1, because 2, as you know, is actually just 2 over 1, which is change in y over change in x. So I'm going to be changing y by up 2 over 1. Then I go up 2 over 1 once again, and I have a couple of points, so that means that I can make my line. Please work. There we go. All right, so now I want to find out, how am I going to have this be true? So if I need this to be true, I'm going to find out whether this side is going to be shaded or if it's going to be this side that's going to be shaded for y is greater than or equal to 2x plus 1. In order to test that, I'm going to do an obvious spot. I can choose whatever kind of spot that I want. So if I choose any spot on this side and that keeps this inequality sign true, then that is good for that side. That means that side gets shaded. If I go on this side and that side holds true, then that means that this is a side that gets shaded and everybody's happy. But if I pick a point over here and it comes out to be not true, like if I have something come out to be where 2 is greater than 1, for example, well, 2 is greater than 1, so that would be true, but if it had 2 is less than 1, that doesn't hold truth, so that means that this side would be shaded. Let's get down with it. So I'm going to pick 0, 0. So I'm going to substitute in here. 0 is greater than or equal to 2 times 0, because I'm just substituting in 0 here and 0 here. So I'm testing to see if this point is true. 0, 0, the origin. Plus 1, and I have 0 is greater than or equal to 1. That does not hold true. 0 is not greater than or equal to 1. So that means that it's not this side that is going to be colored in. It is going to be this side. So I'm going to do it at about a 45-degree angle maybe. Today in class I only was able to do the parallel and perpendicular ones. But I just want them to be parallel with themselves. If I had a ruler with me right now, I would use that. So that is the side that takes it, because this side right here didn't hold that inequality symbol to be true, so I knew that it had to be on the left side of the boundary line. And the boundary line is the pink line that I have there. So done with that one as far as the first equation goes, or inequality goes. So now I'm going to graph the second inequality. Get these out of there. So the second inequality has a slope of -1, because -1 times x is going to be -x. So -1. And -1 is just -1 over 1, because I want it to be that rise over run, that change in y over change in x, so I can see where I'm going to go after I find the y-intercept. Now, they're all not going to be this nice and easy. I might have to maneuver my variables around so I can have it be the slope-intercept form. So I just solve for y if it isn't in that y equals mode in slope-intercept form. So my slope-intercept, I hit it once again at 1. So I have 1 right here again. My slope is negative 1, 1, so I go negative 1, 1, negative 1, 1, negative 1, 1. And there's my other plot point. So I can draw another line. Here we go. So I have negative 1, 1 now. So I have both of those. If they were just equations, those are the lines, and there would just be one solution right here if it was just solving systems of equations. But we have solving systems of inequalities is what we're doing now. So I'm going to find out, once again, I can choose the origin because it doesn't go through there. But I could choose any point. You know what? Here, I'll choose this. I'm going to choose that point, which is going to be 0, negative 2 for my test point. So I'm going to substitute 0, get out of there, 0, negative 2. So it's going to be negative 2. So that would give me 0 is less than or equal to the opposite of negative 2 plus 1. So 0 is less than or equal to 2 plus 1, which is 3. 0 is less than or equal to 3. That is true. So that means that this side of that boundary is going to be shaded in. So I'm going to go, I did 45 degrees that way, I'm going to do 45 degrees this way. Since this point here was true, I knew that I have to shade the bottom part of the boundary line. And this way, I can see exactly what portion of my systems of equations is going to be double-sided. It's the one that looks more like a waffle or a chain link fence. I'll make these thinner. There we go. All right, next one. These ones are not greater than or equal to or less than or equal to. These are just greater than or less than, which means that my line is going to be dotted. Can I even do that? No. All right. So let's do this. I don't have any value of x, so that means that there's not any slope for this guy. So that is very similar to the slope-intercept form, but if it's y equals mx plus b, there's no slope, so that's why x is out of there. And if it's plus b, that means that my intercept is going to be at 0, negative 2. 0, negative 2 for y equals mx plus b. So my slope now is 0, so that means if there's something that has a 0 slope, it's a horizontal line. And it's not greater than or equal to, so this line just shows the boundary as to where that starts. It doesn't include that line, but that's where it starts. And I can choose a point for y. I'm going to sub in the origin there, which is going to be 0, 0. And is 0 less than negative 2? No. No, it is not. 0 is not less than negative 2, so that would be holding it not true. So I have 0 is less than negative 2. No, it is not. So that means that I wouldn't go up. I'm going to go down, for real. Oh, there's my shading. Next, we have to turn this into my friendly y equals mx plus b. I'm going to add an x to both sides of these, plus x, so I can get y by itself. And since I'm not multiplying or dividing by a negative, my sign still stays the same. So this becomes y is greater than x plus 1. That looks more familiar. So I know that my intercept point is 0, 1. And my slope is a positive up 1 over 1, up 1 over 1. And it's going to be a dotted line. Oops. That's bad. Once again, I can use the origin, so I'm going to substitute 0, 0 in for here. 0 is greater than 0 plus 1. That is not true, so that means that I'm going to be going on this side. I'm going on that side, because 0 is not greater than 1. So I go here. I already did that angle. Here. And I would be doing this with my ID or something like that, my school ID. So this one, there's just this little bit of area that is double shaded in. Just that little bit. So these guys here, since it's not too prominent, I'm going to go ahead and just make that a little bit darker. So any point in there, and also would just keep going on forever, where it would be bigger, and it would be all shaded in there as well. Those are points where any point inside those, if you put in something for x and y here, it would count for both of them. Count for both of them. Now let's see a hard one. I don't have time to do. I don't have time to do much more. What do I want to do? Which one's the hardest? I think I'm going to do number 4. Yeah, number 4 is ugly. Okay. This looks nothing like my beloved y equals mx plus b. So I need to make it y equals mx plus b. So I have to solve for y. Solve for y in the first one, so I'm going to get this out of here. Let's see. 2y plus x is less than 4. I'm going to take one x away from here, one x away from here, which leaves me 2y. 4 minus x, or I could just do the opposite of x plus 4 because of my integer rules. And I'm going to multiply this by 1/2, which is the same thing, as dividing by 2. So I have y by myself. So I have 1/2 x plus 2, because I'm distributing this 1/2 into my parentheses, distributive property. So now I have, yay, something that looks much more familiar. I have my y-intercept, I have my slope. My y-intercept is going to be 0, 2. Good year to graduate high school. Then we have -1, 2 is my slope. So my change in y is a down 1. My change in x is 1, 2. That's how I get -1/2. Down 1 over 2 once again. So now I have some plot points. It is a dotted line. I'm going to make it a little bit thicker. How thick is that? Yeah, that'll work. Not at that angle, though. Should go through that point. So down 1 over 2. So we're going through there. Going through there. That's a beautiful line, Mr. Smith. Thanks. Then I'm going to go back, and I'm going to make this prettier. So I have, I'm going to use a different color. So there's the first guy. The second one, 3x minus y is greater than 6. I'm going to subtract 3x, subtract 3x. So I have the opposite of y is greater than the opposite of 3x plus 6. But y is not by itself yet. I need to get y by itself. So in order to do that, I'm going to divide by -1 to both sides. So I'm multiplying by -1 over 1. So that leaves just y here. I'm dividing by a negative. So that means that the sign has to flip. So now I have 3x minus 6, because that flips the signs everywhere. Now I have a -6. Why would they do that? Why would they do that to you guys? Oh well. So that means I have to create that line now for 6, because it goes across the y-axis at -6. Let me verify that I'm doing that right. Yeah, that's right. All right. So -6, I'm going to go from -6, and I go up 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. And that's as much as I can fit on this page. So now I have to make another line. I'll make it a pink line. No, I'll make it orange. Let's keep it consistent. So I'm going to connect those dots with more dots. Oops. I feel like some of the homework responses I saw today, some rough maps. They were mostly, accurate, just like mine is mostly accurate. All right, so there. Now I'm going to test my points. I'm going to test my points here. So let's see if 0, 0 on the first one works. Is 0 less than positive 2? Yes, it is. So that means that this side here is shaded for my first one. Now let's test. Get that purple out of there. Okay. Now let's test. Is 0 less than 6? No, it is not. So that means that I cannot go this way, because that's where the point is that we just tried. But I can, however, go this way. So the side that looks like a lattice, that's the one where all of those values are going to be it. If I wanted to, but I think that I'm really zoomed out right now. Those two there, so everywhere in this spot, in these boundaries that you can see, but also everything beyond. Bad example. Here we go. There. Everything beyond. So if I was going to continue this line on, and I was going to make another one, continue this line on, for that coordinate plane that we just finished, anything at all in this area, if the coordinate plane kept going, let's see if we can turn on these. Yeah. Okay, so if these were the coordinate plane and it continued from there, any point right here for x and y would hold true for both of those inequalities. So that system of equations, or inequalities, sorry. So any point here, any point whatsoever. I'm trying to think of anything else that I could add right now, but my time is out. Yeah, I need to go to a meeting. Yeah, that'll do.